Hey everybody, I got something really cool to show you today. So sorry it's not all in the picture here, it's kind of big and I'm trying to make sure I keep it in the nice box here. But if you can take a look here, I'll show it that way. And then let me slowly do the turn around, turn. Oop, look at that there. See, there's really cool stuff that's happening. Okay, so what we got here is we've got a desktop clock escapement or watch escapement toy or demonstration model or whatever. It's really cool, whatever it is. So this can be found on Thingiverse. Again, I didn't build this. Pardon me, I didn't make this, but I did print it. It's really cool, isn't it? You can get it on Thingiverse yourself if you'd like to. So what's really cool about this is it shows pretty much how a clock works. So let me start from the beginning here. Let's start from the... I've done a few little upgrades to it that you can get on Thingiverse as well, and I'll point those out. The first thing I did was I printed this little cap that's a little different than the original. The original one doesn't have the top, and for those of us who do 3D printing a lot, it's easy to have something with a cap because the printer can easily finish that off. So what we do here is put that on right there, and again the mainspring's right here, and like in my other video, the mainspring here is made out of PETG. The reason for that is that PLA is a little too stiff to make a mainspring out of, just because it gets fatigued real easily. The PETG is a lot more flexible, and it seems to be a little better as a spring. Okay, and as you can see here, we've got the ratchet mechanism. I don't know if you can see that, but get a little closer there. See the little gray part right there? And then the wheel right there, that's the ratcheting mechanism. So what that's going to do is, as I put tension on this spring by winding it up, here comes clicks. Oop, stop that. So you can see how the ratchet mechanism works. It holds the spring from unwinding. Okay, and as we move through the clockwork train, okay, and we got this little clear gear here. This is typically where another gear would be connected to this, and that would go off to where the hands would go. So this would power the hands usually. And if I'm totally wrong, my apologies. But this is where the power would go to the hands, and where you'd actually tell the time from. And the way all this is really cool. This is a lot of math. Who knew math? That would actually be useful again. Tell your fourth grade algebra teacher or fifth grade algebra teacher you're sorry you told her that math, or he or her, that math was never going to be used again. Okay, so this is like I said, this is a lot of math. So what happens is, as this guy is being turned by the mainspring, he is turning the escapement wheel. And what does the escapement do? It does exactly what it says. It helps the power escape. So as the mainspring is turning, if this guy wasn't here with this little guy, the pallet fork, if these little guys weren't here, get a little closer, you can see the pallet fork there, there we go, then the power from the machine would just run right out. So these guys stop the machine from, or the power from escaping too quickly. Okay, and you can see that they're specially created and turned or positioned so that they create like a lock. So as it turns, it goes lock, unlock, lock, unlock, lock, unlock, lock, unlock, locked. So you see how it's working there? See, it's a little hard by doing it this way, but it'd be easier if I just turn this wheel here. See that? So there's locked, unlocked, move, lock, unlock, locked, unlock, locked. See how that's working? Pretty neat, huh? And if I keep moving down here, okay, like I said, this is called the pallet fork. I think it's the pallet fork or the anchor. I think actually the back portion is the anchor. I think this is the pallet fork part up front. And the reason is because it kind of looks like a fork. And typically these would be made out of, in a watch, these little parts in front would be made out of rubies, because rubies are really, really hard. And they last a long time. Okay, and as we keep going along, keep sliding along, keep sliding along. Okay, now I think that little guy in the back, I think that's the anchor. And, or this whole portion is where the screw is, where it connects with. And this is the balance spring. So what's neat is as the main power is trying to turn the whole engine here, this little guy is kind of like a counter spring. So as he's turning, he lets just enough power out to keep the machinery going. So let me scooch this back here, and let me turn this up. Okay, and if I push it all the way back here, hopefully you'll be able to see it moving. Okay, push it back. I don't think it's all the way in the video there. So let me do this here. Let me push it over there. Yeah, you can see it moving. Isn't that really cool? I think it's neat. Again, like, you can go and get this off of Thingiverse today if you want, and print it out. But I hope you had a good time taking a look at this little desktop escapement. Take care. Bye-bye.